Hey everyone, this is Mr. Wyrick. We're going to try to go through this Unit 3 review today. Just a couple of quick things. Right up here at the top, we added in this nice picture for you. No donkeys in geometry. So angle side similarity is not a thing. You can't call AAA. So angle congruence is not a thing. All right. These are the only ways that we can prove triangles congruent. Side, angle, angle, side, hypotenuse, leg, and then we can also use CPCTC, which is corresponding parts of congruent triangles are congruent. Question number 1, if an isosceles triangle, XYZ, has a 120-degree angle at vertex Y, what are the measures of angle X and angle Z? First off, I'm just going to sketch a quick picture. If this one up here is 120, that means the others are going to be acute. They're going to be much smaller. So I know all three angles of a triangle have to add together to make 180. So I'm going to subtract 120 from that. I get 60. It's an isosceles triangle, which means the other two angles, the base angles, are going to be exactly the same. So I just divide that 60 by 2 and I get 30. Each of these angles down here are 30 degrees. Question number 2, write an expression for the possible lengths of side BC in the triangle below. I'm going to label this with an X because we don't know how big it is. But what we do know is that any two sides of the triangle have to add together to be more than the other. So if side X is our biggest side, the other two still have to add together to be bigger than that. 34 plus 48 is 8 plus 4 is 12. 30 plus 40 is 70. So 70 plus 12 is 82. So 82 is my top end. If X were 82, then this wouldn't be a triangle anymore. It would be a straight line. Then what I'm going to do is I'm going to look at my smaller side. Whatever X is, if I add 48 to it, it's obviously going to be bigger than 34 because X can't be a negative number. So I really got to concern myself this direction. X plus 34 has to be more than 48. So I'm going to subtract these. 48 minus 34 is going to give me 12. 14. Hello. So that's the low end of my range there. X has to be more than 14 so that this is not just a straight line. So this is how I'm going to write my possible range of answers. X is greater than 14 and X is less than 82. So written like this, it means X is somewhere in between 14 and 82. Number 3, quadrilateral CDAB is reflected over the line shown, resulting in quadrilateral LMNO. Given the congruency statement CDAB is congruent to LMNO, which segment from LMNO corresponds to DC? I don't even need the picture for this. If I'm going D to C, then the correct answer is going to be the second one to the first one, just like the other. So line segment ML is going to correspond to DC. So if I'm going specifically like this, if I were to take this paper and fold it in half and transfer that arrow would go just like this. Okay, if you don't believe me, what you can do for some congruent statements like this is actually hold up your phone screen here on this line where it's supposed to reflect and look at the reflection of it. You should be able to see it. I don't know if that'll be so much help during the test, but as we get further into reflections, that might be a nice little way to move your way through it. Okay, question number 4, triangle WXY is isosceles. The measure of angle W is 70. The measure of angle X is 55. What's the measure of angle Y? Again, I've got an isosceles triangle. I don't have to draw it to scale. One vertex is 70 degrees. One vertex is 55 degrees. I know the whole thing has to equal 180, so I can just do some quick math. I subtract 70 from 180, I get 110. I subtract 55 from that, and I get 55. So these two bottom angles are the ones that are going to be congruent. They are my base angles. So that means angle Y and angle X are base angles. They're the ones that match up. And it wouldn't matter if I drew this like sideways and said, okay, this one is the 70 and these two would be the 55s. Wherever the 55s are, those are the base angles. Wherever the 70 is, that's the vertex angle. Okay. Try to speed this up a little, move this along. Question number 5, what shows two triangles that are congruent by side, angle, side? It's this one over here, the side, and then the angle, even though it's 90 degrees, and then the side. This one also has the side, then the right angle, then that side that they share. So this one should be D. This one's trying to be a donkey. This one's angle, angle, side. This one's just side, side, side. Number 6, find the value of x in this figure. The exterior angle is the same as adding together both of the remote interior. 8 plus 5 is 13, and 5 plus 3 is 8, plus the one more is 93. This is a 93-degree angle, even though it's totally not to scale there. You could also add these two together, get 93, subtract that from 180, get 87, and then know that these two add together, and 180 minus 87 is going to be 93, no matter what you do. Either way is fine. I'm just showing you the shortest, most efficient way to do this. Number 7 is one where you have to be careful. If this is x, then this is x. And I know that all of the angles of a triangle are going to add together to be 180. So I would subtract my two x's to get what this angle is going to be. Now, it seems like you could perform some algebra on this and divide both things by 2 and call this option C. But you can't, because you would have to do some geometry and split this in half as well. And that's just not what's going on here. We need the full 180. We need to subtract 2 of that base angle. If you don't believe me, then pick 35 for your angle. 35 and 35 would be 70, and 180 minus 70 would be 110. So your top angle would have to be 110. If 35 is my bottom angle and I subtract that from 90, I would get 55, which is half of what I need it to be. Okay, so option D here is going to be the one that works. Number 8, which one shows two triangles that are congruent by angle, side, angle? This one's our old friend side, angle, side again. This is the one that's angle, side, angle. This one is all 3 angles. Remember, you can't call AAA. This doesn't work. And this one's trying to be a donkey, so this one doesn't work either. If you pay attention to that stuff on the front of this review, you should be able to cut a lot of these questions like this down to at least 50-50. Okay, question number 9. Quadrilateral OLMN is translated up and right to form triangle ABCD if OL is 4, LM is 5, MN is 5, and NO is 7. What is the length of side DC? Well, it should match up over here, and it should just be 5 units, whatever those units are. Inches, cookies, whatever we're measuring in today. In this diagram, segments AB and AC intersect line M at points, I think it's supposed to be C and B on this one, respectively, or B and C, or whatever it is. Classify the triangle by its side and its angles. These are 115. And without doing the math, I know that that means that these two are going to be equal, which means these sides are going to be equal, which means we have an isosceles triangle. And if this is 115, this is going to be less than 90. This is going to be less than 90, and this should not be a right angle, so this is probably going to be acute. If I go ahead and do the math, 180 minus 115 is the same thing as 80 minus 15, which should be 65. If this one's also 65, that means this top angle is going to be 50. 65 and 65 would make 130, and 180 minus 130 is 50. Which pair of triangles can be proven congruent by side, side, side? That would be A here. All 3 of the sides are marked. There are no angles marked. This one's trying to be a donkey. No, thank you. This one is, I think, doing a hypotenuse leg, which is nice, but not what we're looking for. And this one is side angle side, not side, side, side. Number 12, what additional information is needed to prove that these triangles are congruent using angle side angle? This one's tricky because we are given an angle and we are given a side. We need to pick an angle to get angle side angle, but it needs to be the one that the side that's selected is included in between those two angles. So it's going to be angle A over here and angle T over here. So we need angle A to be congruent to angle T. Okay, almost done. I've only taken 11 minutes of your time so far. Number 13, could triangle ABC be congruent to triangle DFE? In this case, we've got a right angle in both of these, and we're looking to try to do a hypotenuse leg kind of situation. This also appeared in our notes. This one's a no. The hypotenuse of one, which this is the hypotenuse, it's across from the 90-degree angle, is looking at the leg of the other one. And they're equal. They are both marked as 8. And that is not supposed to happen. The hypotenuse can't equal a leg. Number 14, which congruence theorem can be used to prove triangle ABC is congruent to triangle DEC? In this case, we are given a side. We are given a 90-degree angle for both of them. If we knew that AC and CD were congruent, we could pull a nice hypotenuse leg here. If we knew that BC and CE were congruent, if C was a midpoint of that, we could have a nice side angle side. We don't have those options. If we knew that these were parallel lines, we could do alternate interior angles and have an angle side angle. What we have instead is we have a set of vertical angles right here, centering at C, going across into both of these triangles. Since those are vertical angles, I have an angle in both of them, another angle in both of them, and then a side that is not included between those. I can use angle, angle, side congruence. And then number 15, in the triangle below, find the measure of TSU. That's this interior one. Make sure you follow the letters in the order. That TSU is on there. We could have maybe called it angle S, but there's an interior and an exterior angle there at point S. So it might throw off our calculations if we did that. If this is 140, this whole arc here, that's a linear pair that has to add up to be 180. This is 40. And all three angles of a triangle equal 180. So this is 60 and 40, that's 100, which means this bottom one needs to be 80. So the measure of TSU should be 80 degrees. Hopefully this helps you out. Make sure to finish up this review and get it turned in on the assignment that this video is attached to. And good luck on your Unit 3 test.